One of the course level learning objectives for Math 10 is to be able to decide what is the correct data type to use in Python for a given task. And let me give you an example of 4 data types that in some ways are pretty similar and say what some of the advantages and disadvantages are among these. So here I started out by defining this variable myRange to be range 4. And it's kind of hard from that to tell what my range is if you don't already know range well. Like if I try to display it, it just says range 04. So that doesn't help me very much. But this is a really important notion of how you can convert from one data type to another data type. So here I'm trying to convert from whatever this is into a list. And here I'm trying to convert from whatever this is into a tuple. So if I ask what is my range, like what's its type? Okay, again, it doesn't tell me that much, it just says it's a range, whatever that is. But if I ask what is the type of my list, okay, that's a list. And so it doesn't seem like it's helped very much. But if I look at my list, okay, then this is more helpful than when I looked at my range. So these are the elements that are in my list, and my tuple and my set are going to be very similar. So my tuple looks almost exactly the same. Only difference is it has round parentheses instead of square brackets. If I look at my set, again, it looks very similar. Only difference is now it has these curly brackets on the outside instead of square brackets for a list or round parentheses for a tuple. And the functionality of these is pretty similar. For example, I can say true or false, is 2 in my range? And it says true, is 2.1 in my range? And it says false. If I say is 2 in my set? Okay, it says true. If I ask is 2.1 in my set? Again, it's going to say false. So a lot of the functionality is pretty similar. So what are some advantages and disadvantages between these different data types? Well, a big advantage of range over the other ones is range takes up much less space. So for example, let me import a library that's built into Python called sys for system. And then let me try sys.getSizeOf, and then my range. So this is going to tell me how many bytes in memory, I believe, does this my range object take up. Okay, and what if I ask sys.getSizeOf, and then how about my set? Okay, so you can see that it's much bigger. And if I try something like sys.getSizeOf, and then how about range 1,000,000, 10 to the 6th? You can see that it's still just size 48. Whereas if I were to ask, what's the size of, let's convert it into a list. So you should think of this as a list containing the numbers from 0 up to 1 less than 1,000,000. So you can see that this is huge compared to the original range, even though in a sense they have the exact same data. Okay, like the elements inside of this list are the exact same as the elements inside of this range. Okay, and it would be the same if we tried it for set. Okay, I guess that's even bigger. Or if we tried it for tuple. Okay, maybe that's a little smaller than the original list, but you can see they're all many orders of magnitude larger than the original range object was. So that is a big advantage of range. And you can even have things like 10 to the 60th, okay, which you could never even convert that into a tuple. You would get an error. So that is an advantage of range over these other ones. What's an advantage of, for example, a tuple over list? Well, say I try to create a set, like let's put 314 into a set. So one thing to notice is that sets do not have a notion of order. Just like if you've taken Math 13, you've seen that the mathematical notion of a set doesn't have a notion of order, and it's the same for the Python notion of set. Okay, they're not ordered. Might look like it's increasing, but that's not something you should pay attention to. That's just some artifact of how it gets displayed. And if I put 3141 and try to put that into a set, then the second one disappears, and that is because sets are not allowed to have repetitions. So one possible advantage of tuple and list over a set, I made this set by using curly brackets on the outside, and if I try to do the same thing with a tuple with round parentheses, it keeps the same order and it keeps the repetitions. If I try to do the same thing with a list, so with square brackets on the outside, keeps the same order and keeps the repetitions. So I got off on a little bit of a tangent, but what I originally wanted to say was, what's an advantage of a tuple over a list? Well, here is one advantage. If I go back to this 314, hey, let me get rid of the second one, and I try to put this list inside of it. So you should think of this as I'm trying to make a set. The set is supposed to have 4 elements in it, a 3, a 1, a 4, and this list. Okay, those would be the 4 elements. And you see I get this type error that says you're not allowed to put this list into a set. Okay, and the technical reason is that it's not something called hashable. Whereas if I try to put a tuple in, it's going to work. Okay, I mean, again, the order gets changed a little bit, but this is some length 4 object. It's some length 4 set. Okay, let me convince you I can really check the length of it. len. So that's some length 4 object that contains 1, 3, 4, and this tuple. So that is one advantage of tuple over a list, is that tuples are what's called hashable, and for us the most important aspect of being hashable is that it can go into a set. Okay, we'll also see some things later, like involving NumPy, where being hashable is important. So what's an advantage of a set over a list? So let me give an example of this, and then maybe we'll be done. So let's make a large range object. So let's say range from 0 up to 10 to the 7th, go up by 4. And let me just call this, how about R for range? And let me convert that into a set. Okay, I'll call this S for set. And then let me ask, how about, is 1, 2, 3, 4, 5 in S? Okay, I get the answer false. And let me check how long that took. I'm going to check using something called the timeIt magic function. So %% timeIt. Okay, no spaces in here. And then I'm going to ask the same thing. And what this does is Python runs this command a few times, and then it computes how long did it take on average to make this computation. So in this case, we're trying to check, is this number 12,345, is that in the set S? And now let's make, how about, I'll call it new list equals list R. Okay, and let's try to do the same thing for checking how long does it take to check whether this element is inside of new list. So this one took nanoseconds, so this is like a billionth, I think, of a second. This one is taking milliseconds, so like thousandths of a second, so this is much, much slower than the other one. And it would be the same sort of thing if we did it with tuple. And what is an advantage of a list over a tuple? Well, for example, say I make T for tuple R. Okay, and then say I try to put the number 100 onto the end of this tuple. Okay, I get this error that tuple has no attribute append. And the reason for that is that these tuples, they're not supposed to change once they're created. That's related to the fact that it's hashable. Whereas if I take new list and try to append 100 to it, hey, that works fine. If I want to look at what's the last element in new list, I get this element 100. Okay, if I want to ask what's the second to last element in new list, hey, I get this element. So those are some of the advantages and disadvantages among these different data types of list, tuple, set, and range.